Hello, my name is Ilgiz Murzakhanov, and I will present our work on priority lists for power system investments, namely allocating Phasor measurement units. This paper is the result of collaborative work of the Technical University of Denmark and Skolkovo Institute of Science and Technology. The evolution of the power system requires continuous updating of its components to meet requirements of reliability, sustainability, and economic efficiency. Phasor measurement units are becoming one of the central and most promising components of the modern power system. The installation of PMUs in power systems can solve two problems: provide observability of the system and increase measurement accuracy. The latter is achieved by the property of PMU measurements, which are time synchronized and sampled 30 to 60 times a second. However, the installation and maintenance costs of PMUs are not negligible. For this reason, the installation of PMUs is done in multiple stages, when at each stage the best location of PMUs is defined for the given budget. In our work, we present methodology for building a priority list for the multi-stage PMU placement problem. For calculating measurement accuracy, we utilize the residual sensitivity matrix S. Diagonal elements of the matrix refer to the variance of the residual errors. In our work, we find out that the average of diagonal elements of the matrix S is the most informative metric. We show that a lower average value corresponds to higher measurement accuracy. Let's consider the IEEE 14-bus system. Installing PMU sensors in node 2, 6, 7, 9 makes it fully observable. Next, we additionally want to install K sensors so that our accuracy metric is maximized. Can we guarantee by allocating one PMU sensor in K steps leads to the same result as locating K sensors in one step? The answer is no. In our paper, we show that these two approaches are not equivalent to the considered problem, and we prove that problem of locating PMU sensors to increase measurement accuracy doesn't have modular property. In our work, we consider two frameworks to install PMUs. First, budget constraints algorithm, which at each stage chooses the best K nodes. It can be referred to as a global optimum within each stage. The second is the greedy algorithm, which chooses the best one node per step. From the table, we see that the budget constraint algorithm doesn't necessarily keep the solutions of the previous stages in the solutions of the next stages. For example, at the second stage, it selects nodes 8, 14, but at the third stage, selects nodes 8, 10, 11, thus eliminating the previously selected node 14 from the third stage. The greedy algorithm at the first stage follows the same logic as the budget constraints algorithm. However, beginning from the second stage, it preserves the previously made decisions in future solutions. We conclude that the greedy algorithm is the only alternative for practical installation of PMU sensors in the power systems, because it preserves the previously found solutions in all the next decisions, and it provides similar results in terms of average of diagonal elements of the matrix S as the budget constraint algorithm. If you have further questions or suggestions on collaboration, feel free to contact me by the shown email.